Traffic is one of those problems so woven into daily life that most people stop seeing it as something that can be fixed. You get into your car, buckle up, move a few feet, stop again, sigh, and resign yourself to a slow crawl that steals hours from your life each week. It becomes normal because everyone experiences it, and shared suffering somehow feels permanent. But Elon Musk doesn't look at a line of cars and accept it as an unchangeable reality. He sees billions of wasted hours across humanity. He sees parents stuck instead of being home, innovators unable to create, and people losing precious pieces of their lives to a problem that seems mundane but is actually monumental. The real issue isn't how many cars we have. It's that we're trying to shove three-dimensional lives onto flat strips of asphalt. Humanity lives in a world full of vertical possibility, yet our transportation mostly stays glued to the ground. It's like trying to move a river through a drinking straw. You can widen the straw, add more straws, or redesign their shape. But the limitation remains. Everything is trapped at one layer. So Musk looks to the dimension we've ignored. Upward. Instead of optimizing traffic jams, he wants to skip them entirely. Instead of building better cars to sit in gridlock, he imagines a new way to move that frees people from the ground. That idea takes shape in the form of Tesla's electric jet. The project isn't just about engineering a new kind of aircraft. It's about transforming the way we think about distance and time. Imagine needing to get across an overcrowded city. In a car, you'd budget 45 minutes. Maybe an hour. Knowing stoplights and unpredictable congestion will slow you down. But if you had a vehicle that could lift straight up, rise above the rooftops, and glide smoothly to your destination, a stressful hour-long commute shrinks to 5 minutes. That isn't a minor upgrade. It completely reshapes a person's daily life. You gain back days of your year. You can choose where to live based on lifestyle instead of traffic patterns. And most importantly, you reclaim time. The most precious and limited asset any human has. What once felt like fantasy is now edging into reality. This new vision comes from frustration with the status quo. People have spent decades making cars faster, safer, and more efficient. Yet the environment those cars operate in has barely evolved. Highways get repaved, lanes get widened, traffic systems get digitized, but the core structure remains stubbornly flat. Tesla's approach is not to wait for cities to change. It's to leap above the cities entirely. The idea is to create a network in the sky, a new kind of mobility that makes the world feel smaller and life feel bigger. For many decades, flying cars have lived in the realm of imagination. Animated shows showed families gliding between floating buildings. Sci-fi films depicted commuters zipping through the air, while the world below looked like a forgotten maze. Yet those visions always felt just out of reach. The obstacles were enormous. Traditional engines were too bulky and too loud. Designs that tried to merge cars with wings always resulted in mechanical compromises. A vehicle that could lift straight up like a helicopter but cruise with the efficiency of an airplane seemed like a contradiction. The physics were unforgiving, the materials too primitive, and the technology too underdeveloped. But the world has changed dramatically. A flood of breakthroughs has altered what is possible. Battery chemistry has advanced far beyond its early limitations. Lightweight composite materials have evolved into aerospace-grade superstructures. And artificial intelligence now handles tasks that once required teams of experts. This convergence has taken the idea of a personal electric aircraft, from maybe someday to the prototypes, are almost here. Building such a jet is no longer a question of producing enough thrust or making it light enough to lift. It's a matter of perfecting safety, efficiency, and cost. Governments also recognize the urgency. Overloaded cities are cracking under the weight of growing populations. Roads fill faster than they can be expanded. Infrastructure ages faster than it can be repaired. Because of this, national agencies like NASA and the FAA have been encouraged to accelerate their work supporting new forms of aviation. They see electric vertical takeoff aircraft as a way out of the gridlock crisis. These types of jets don't need massive airports or long runways. They can lift off from a small pad, even from the top of an office tower or the edge of a neighborhood. This makes point-to-point air travel possible on a personal scale, not just for wealthy travelers on chartered flights, but for ordinary people who simply want to move without being stuck on a highway. The flying car dream hasn't disappeared. It has matured. Instead of a car with foldable wings, the future looks more elegant. A sleek electric jet built entirely for the sky. It's quiet. It's efficient. It's smart. It doesn't try to be a road vehicle. It's a new species of transportation altogether. And Tesla is leading the way in shaping what this new chapter looks like. Tesla's ability to develop such an aircraft comes from something unique about the company. It is not merely a car manufacturer. It is a technology company that happens to produce vehicles, and it is closely connected with SpaceX. A company that builds machines capable of surviving the violent journey into space and the scorching fall back to Earth. That shared ecosystem gives Tesla knowledge and tools no other automaker has. They understand batteries better than anyone. They have some of the most sophisticated artificial intelligence training systems on the planet. And through SpaceX, they have access to materials and engineering practices that exceed aerospace standards. The foundation of the Tesla jet lies in its materials. Aircraft must be as light as possible while remaining incredibly strong. Every gram matters when a vehicle has to lift itself into the sky. Traditional metals often struggle to balance strength with weight, but SpaceX has spent years perfecting exotic alloys and composites. Drawing from that experience, Tesla's jet uses a combination of advanced carbon composites and a special aluminum-lithium alloy. These materials aren't found in everyday cars. They're closer to what you'd see on a spacecraft or a high-performance rocket. The carbon composite provides tremendous impact, resistance, and long-term durability. The aluminum-lithium alloy is far lighter and stronger than typical aluminum used in commercial aircraft. Together, they form an airframe that can endure decades of flight without the fatigue or corrosion that plague older planes. Estimates suggest the jet could operate for more than 30,000 flight hours, which translates into more than 20 years of daily use. The battery at the core of the aircraft marks a major turning point. Instead of traditional lithium-ion chemistry, Tesla is preparing to use aluminum-ion battery technology. Lithium-ion cells revolutionized electric cars, but for aviation, they still have limits. Aluminum-ion batteries solve several of those issues. They are far safer, virtually eliminating the risk of thermal runaway, which is vital for flight. Aluminum is also incredibly abundant, hundreds of times more plentiful on Earth than lithium. This abundance could cut costs and reduce reliance on complicated mining supply chains. The lifespan of these batteries is also remarkable. With the ability to endure over 10,000 recharge cycles, they last far longer than today's EV batteries. And they're light enough, dense enough, and powerful enough to lift the jet off the ground. At more than 500 watt-hours per kilogram, the energy density exceeds what many experts believed possible for aviation. This allows the jet to travel around 1,000 kilometers, over 600 miles on a single charge, while maintaining a cruising speed in the 450 to 550 mile per hour range. Charging is just as important. Instead of waiting hours to refuel, the Tesla jet can fully recharge in under half an hour. That means the aircraft can land to power up during a short break and be ready for its next trip without long delays. This keeps costs down and makes the jet practical for frequent use, whether for private owners, businesses, or air mobility networks. A standout feature of the jet is its near-silent operation. Helicopters vibrate, roar, and thump through the air with mechanical chaos. They rely on exposed rotors, gearboxes, and moving parts that produce deafening sound. Tesla's design replaces all of that with enclosed electric ducted fans. These fans spin inside cylindrical housings, dramatically reducing noise. Combined with AI-based control systems that constantly adjust thrust for smoothness, the jet produces less than 55 decibels of sound from a distance of 100 feet. That's quieter than two people chatting in a room. In a city, this matters. Aircraft that can fly without disturbing residents or disrupting neighborhoods are critical for any large-scale adoption. Inside the jet, Tesla abandons the traditional cockpit entirely, instead of switches, gauges, levers, and panels. The interior looks more like a high-end, minimalist lounge built for comfort and clarity. The front of the cabin is dominated by a single sweeping old display. Instead of rows of instruments, you have a visual command center that blends navigation, system monitoring, and scenic information into one intuitive interface. The controls aren't physical because the pilot isn't expected to manually operate every detail. Tesla plans for an AI-assisted or AI-led flying experience where the user interacts with the aircraft through simple inputs, not complex piloting skills. This jet, in many ways, is designed as a bridge between fully autonomous flight and human-guided travel. The AI handles tasks that normally require the